Let's continue with our discussion on congruent triangles. So these are the examples. So we will try to identify if two triangles are congruent or not. So we already solved letter A and we found the congruent triangles and the reason. So let's proceed now to letter B. In letter B, so we have a triangle ABC. So this is a triangle ABC, and we want to find a triangle that is congruent to triangle ABC. When you look at it, you have like an idea that the possible congruent triangle should be ADC, the triangle ABC. So how do we know if this triangle ADC is really congruent to triangle ABC? So we need to check if we can satisfy SSS, ASA, SAS, SAA, or the HL theorem. Now, so let's take a note of what we have. So the side AB, so this side AB, so this is the side AB, is congruent to the side AD because they have the same symbol. So we have side. And the angle BAC, so this angle is congruent to angle DAC. So we have angle and angle. So as we can see, we already have S and A. So we just don't know if we will be able to get ASA, SAA, or SAS. Now we don't see any other symbol for angles, so it seems like we cannot create, or we cannot have an SAA or AAS theorem that can be satisfied. But when you look at AC, so this side AC, an important thing about side AC is the DC, and it's also the side of the triangle ADC. So definitely AC is equal to itself because it's the same AC. So I can take this side to complete the requirements. So we have side, angle side, side, angle side. So this means that the two triangles are congruent. So we were able to find that triangle ABC is congruent to triangle ADC. And this is through the SAS postulate. Okay, so when you prove or when you identify if two triangles are congruent, you just have to check, can you satisfy SSS, ASA, SAS, SAA, or the HL theorem? Okay, so let's move to the next one. So letter C. So there's a square symbol here for an angle, so that means this is 90 degrees. Okay, so we are hoping that we can satisfy the hypotenuse leg theorem, and if that will happen, then we can conclude that the two triangles are congruent. Again, when you look at it, when you compare the two triangles, when you find two triangles, you can see that the triangle ABC is somehow the same as the triangle ECD. So how do we ensure, or how do we know that the two triangles are congruent? So we have to check the hypotenuse. So the hypotenuse is the side opposite the 90 degrees. So there's a symbol here, and there's also a symbol, same symbol, on the hypotenuse of the second triangle. So H is checked. Okay, so we have the hypotenuse. Now, for the L, so we inspect the legs. So this leg of the triangle has this symbol, and you can also see that on the side of the second triangle. So that means the leg of the first triangle is equal to the leg of the second triangle, or they have the same length rather. So that means we were able to satisfy the HL. Since we have satisfied the H and L, then that means, or we can conclude, the triangle ABC, so ABC, is congruent to triangle ECD. You have to be careful when you name the triangle. Since it started at A and goes to B, so from the tip point A, so we should start at this point E, and it will go down to B, so following the hypotenuse, so you should select ECD and not EDC when you name the other triangle. And again, the reason for this is that we were able to satisfy the HL theorem. So the two triangles are congruent. Now, so this letter D, so triangle ABC is congruent, supposedly congruent to this, and when we check, you have the side and the side, you have the angle and the angle because you have the symbols, and then the third side and the third side, so this is under SAS, so they're congruent. So to name the triangles, the other triangles in which ABC is congruent to, so we should follow the flow. So this is A, it will go to B, so from the angle, from the known angle, so we expect to start with F, it will go to B following the symbol, so from F you follow this side, so it's FB, and eventually you can just add the E. Okay, so that's it. So although it's very clear from here that the two triangles are congruent, it is important for you to know how the two triangles are congruent. That means you should know how SSS, SAS, ASA or SAA, and HL theorem can be applied. And aside from that, you have to know how to write the letters in the triangles properly, because you have to make the sides correspond to each other appropriately or correctly. Okay, so that's it. So I hope you understand how to identify triangles that are congruent, and how to name the triangle congruent to the given, and how to state the case of congruency. That's all.